of x is a function of x because it is determined by the x value, and f of x, and this is capital F of x, is the area underneath the curve. And that's lowercase, and it does matter. Okay, so if I wanted to find the change in capital F of x, okay, so that would be, we're going to the right, here would be the little tiny rectangle that represents
dx.
Well, the change in capital F of x. True? That rectangle?
Mm-hmm.
And what are the dimensions of that rectangle? Well, how tall is it?
F of x.
Little f of x, right?
Times
And
dx.
how wide is it? Dx or
X.
delta x, right? Okay, so you can say that delta, or change in capital F of x, is equal to base times height. Should just added it. True statement? Okay. We're gonna divide by delta x. So the change in capital of f of x is equal to f of x. So in calculus terms, we can say d that dx. So basically, the derivative of capital F of x is f of x. Now, is that significant?
Probably.
It's really, really significant.
So much.
Okay? So what we found is the derivative of the area under the curve is the curve itself. So then, like, the converse of it would be the integral of the curve is the area under the curve. We already talked about that, but that's how they're related using this terminology. Okay? Do you remember what we had the velocity? We just did a rectangle, I think. If this is v of t, and this is, we'll say, meters per second, and this was time in seconds. So the area underneath this velocity curve, remember what that gave us?
Distance.
It is the distance, right? So the rectangle, if you're multiplying the time in seconds, whatever that is, times the velocity in meters per second, if you multiply those, the seconds are going to cross off and you just get meters. Okay, so the area underneath the velocity curve is going to give you the distance. Area underneath any curve is going to give you the antiderivative, or the integral. Alright, so can we integrate, what was it, sine x dx from 0 to pi? Wasn't that what we said was 2? Okay, so if we know what the antiderivative of sine is, then we can evaluate it from 0 to pi. Okay, and that will give me the area underneath the curve. Zero to pi. So all I have to do is do capital F of B minus capital F of A, and that will give me the area under the curve. We find the antiderivative of it, evaluate it from 0 to pi, so it would be capital F of pi minus capital F of 0, where capital F is the antiderivative. So does anybody know what the antiderivative of sine x is?
The integral.
Negative cosine x? Because if you find the derivative of negative cosine, you'll get sine x, right? So, negative cosine of pi minus negative cosine of 0. The cosine of pi is negative 1, opposite of negative 1 is 1, plus the cosine of 0 is 1, 1 plus 1 is 2. So we need to find the antiderivative of whatever we're integrating, and we're going to evaluate it from a to b. So you do antiderivative of that minus antiderivative of that, and that will give you the area of the curve. Okay, so that's how derivatives and integrals are connected. It's called the fundamental theorem of calculus. That sounds pretty important. Okay, and there's 2 parts to it. This is part 2 actually. You learn part 2 first.
Why is it part 2?
I don't know. I don't know why it's not called part 1. So, let's try something.
We need part 1.
Let's go antiderivative of 2x plus 3 from 1 to 4. Can we figure that out?
With our calculators, yes.
No calculator.
Find the antiderivative. You showed me how to. It's very good.
So see if you can find the antiderivative and evaluate it. X squared plus 3x. Okay, so now we're going to evaluate it from 1 to 4. So it's 4 squared plus 3 times 4 minus 1 squared plus 3 times 1. 16 plus 12, 28 minus 4, which is 24. Thank you. Yeah.
Why don't you have to add the constant c in?
I'll talk more about that tomorrow. It's in your notes. It's. But the short answer is.
Oh, yeah.
The short answer is, if this is called a definite integral integrals have boundaries of integration. If you have a definite integral, you do not add a plus c. If it was an indefinite integral, we've done that before, where we did like the acceleration, velocity, and did plus c. Indefinite integral would be this. So our ants, I'm having a hard time with that plus sign. The antiderivative would be plus c, because there's no boundaries of integration.
How would you go? If you don't want it, never mind.
Yeah, so there's infinite answers there, that's why we do a plus c. Alright, so you can kind of see where this course will take us. We don't have the ability right now to figure out a whole lot of antiderivatives, right?
So we will find a way.
We'll have several different techniques that we'll have to use. Like if you had let's say, just go back to sine. Do we know what the antiderivative sine of 4x is?
Not in a single way. Wait, a chain rule.
Negative 1/4
Yes. Yes.
So if you aren't sure, you could do the derivative, right? But you're saying negative 1/4 cosine of 4x? Let's do its derivative. So the derivative of negative cosine, this is going to float, so the derivative, we're going to get sine of 4x. That's a real good 4. Times 4. And you still have the 1/4 out front.
Negative 1/4.
No.
Well, that's how you did it. So yes, we do end up getting what we started with.
Wow, you guys are smart. Remind me of this class.
Okay, so that takes a little bit of thinking. There's a technique called U substitution we'll learn, and it'll take a lot of the thinking out of it for that easy.
I love not thinking.
Our goal is to eliminate as much thinking as possible here.
Always use calculator.
All right, questions on that stuff?
The homework, we don't have to do that.
We'll go through more proof stuff.
Proofs.
on Monday. Even toss
Not
in
tomorrow.
mean value theorem.
No.
For integrals.
No.